In this video, I'm going to show you how to do OCR A-Level Maths, Paper 1 from June 2013, Question 1. My name is Sunil Tanna. I'm a tutor and author. I live in Buckinghamshire, England. I'm available for one-to-one tuition both online and in person. So let's get started. Question 1. In the triangle ABC, the length AB is 6 centimeters, the length AC is 15 centimeters, and the angle BAC is 30 degrees. Calculate the length of BC. So the first thing we need to do is have a little sketch maybe and figure out a little bit about what this triangle looks like. So if we're starting with the angle, we're starting from B, going towards A, and then going towards C, we have a 30-degree angle. So this is B here, A here, and C will be somewhere along this line. And we can see that the bottom side here, AB, is 6 centimeters. The other side is 15 centimeters. So I guess it's going to go quite long up here, 15 centimeters, and C will be somewhere up there. And we have a triangle that looks something like this. Now the question is to find the length of this side here. And this is quite a common situation, two sides and the angle between, which we can use the cosine rule to, or cosine law sometimes it's said, to find the missing side. So the cosine formula is a squared is equal to b squared plus c squared minus 2bc cos a. And the rule for these is the lowercase letters correspond to the length of sides, the capital letters correspond to angles, and we always have to match them up so that an angle is with the same letter is opposite the side with the same letter. So let's have a look. So with only one angle in this formula, so this angle 30 degrees is A. Now these letters may or may not correspond to the letters in the way that the question is given to us. By coincidence, that is also A in the original triangle, but that doesn't necessarily have to be the case. So our formula letters are separate from the labeling in the question itself. Okay, so if the 30 degrees is A, the opposite side from 30 degrees is side BC, which is small a. And then the other side, 15 and 6, we can do whichever way around we like. So we'll call this side B and this side C. So plugging that into the formula, the length of BC will be the same as small letter a, which will be the square root, and we can start plugging these numbers in. B is 15, so 15 squared, plus C is 6, so plus 6 squared, minus 2 times B times C times cos of capital A. And then we put that into our calculator and we will get 10.3 to 3 significant figures. Now this is a length, so it's 10.3 centimeters. Okay, part B of the question says, calculate the, D is the point on AC, so somewhere along this line, such that BD is 4 centimeters. So somewhere on this line is point D. It could actually be more than one place, because maybe there's two places which would be 4 centimeters away from B. In fact, we'll see that there could be two possible places for that. Okay, let's draw an example of that triangle here. So we have the bottom side here, which is 6, which is AB. We still have this 30-degree angle here, and point D is on this line here, and DB is 4 centimeters, which is the line I've shown in the lighter pencil line here. So if we look at this, we have an angle and its opposite side, and we're asked to find the angle at the top. So we've got an opposite pair as well. This is an ideal situation for the sine rule or sine law, and what we do is we put the unknown on the top of a pair. So in this case it will be sine of ADB over its opposite, which is 6, is equal to sine of 30 over 4. So then we can do sine of ADB is equal to 6 times sine of 30 over 4. And then we can use inverse sine on our calculator once we've calculated this value to get the angle. And you'll find that angle ADB is 48.59 degrees. But that's not the only possibility. As I say, maybe there's more than one angle that this could be, because there could be two lengths of 4 centimeters. It could be an obtuse angle. So the other option would be 180 minus 48.59 degrees. And that will work because We've only used 30 degrees out of the 180 in this triangle in here, so we have up to 150 degrees for these two angles here. So if we calculate that, the final answer is angle ADB is equal to 48.59 or 131.41 degrees. And that completes question 1.